Hello, in this video, we're going to look into three more rules of differentiation. These are product rule, quotient rule, and chain rule. And these are going to help us find the derivatives of more complex functions. For example, and in this case, we have product rule. And in this case, f of x is the result of multiplying the functions g of x and h of x. And below, we can see the rule is actually here, which is this is product rule, and the derivative of f of x is equals to g prime times h plus g and times h prime. So, and we're gonna use an example to understand how we can apply this rule. For example, what is the derivative of f of x, which we have here. And in this case, we actually, if we wanted to use some algebra, we could expand these two factors and then apply just the rules of differentiation that we learned in the previous video. But let's actually use product rule because that's what we're gonna do here. For example, so the first factor, 2x cubed plus 1, is we're gonna let it be g of x, and the other factor, 3x squared minus 2, is gonna be h of x. So we're just gonna apply the rule as it is. Here we have f prime is equals to, so you're gonna take the derivative of g of x, which is 6x 6x, because the derivative of a constant is 0. So that's what it is. And actually 6 squared. I was missing the x squared because we have a cube. And the h of x stays as it is. And plus g of x, we just copy everything down, and h prime, which is actually 6x. So at this point, we have the derivative of f of x, but we can just do some algebra to clean it up a little bit more. And we're gonna have 18x to the fourth power minus 12x squared, and distribute this 6x, and this becomes 12x to the fourth plus 6x. We can just combine like terms right now, and we have we have 30x to the fourth power minus 12x squared plus 6x. And if we want, we can just actually we can factor out as 6x. So 6x times 5x cubed minus 2x plus 1. So after applying the rule, we just do algebra. So very simple. And let's go to the next one. And here we have quotient rule. And in quotient rule, f of x is equals to the quotient of two functions. In this case, we can see that g of x is over h of x. So the derivative of f of x is given by the formula here. I'm not gonna repeat all this, so just let's go to the example. What is the derivative of f of x? And we're gonna let the top is obviously g of x, like as we have it in the formula, and the bottom, the denominator, is gonna be h of x. So we're just gonna go straight and apply the formula. So f of x prime, the derivative of f of x, is equals to the derivative of the top, which is 2x times h which is 2x plus 4 minus g of x, x squared minus 2, and h prime of x, which is the derivative of a and of h, which is only is 2. And that's all over h of x squared. So let's put that in parentheses and square. So usually the bottom, we just leave it as it is. We don't want to mess with that unless it is obvious that we can cancel something out. But just for the sake of doing this quick example, we're just gonna leave it as it is. So now just do some algebra. So on the top, 4x squared plus 8x minus 2x squared plus 4. And that's all over the 2x plus 4 squared. We can actually combine some like terms just to make it look cleaner. And so yeah, 2x squared plus 8x plus 4 and all over 2x plus 4 squared. And that looks clean enough. So we're just gonna leave it like that. And the third rule is known as chain rule. And this is used for a composite function. And I like to summarize it like this. For example, h of x is the outside function and g of x is the inside function. So h of x is the outside function and g of x is the inside function. Actually, we can write it so actually we can write it as derivative of the outside function. So derivative of the outside function and derivative of the inside function. Derivative of the inside function. So in this case, we can say that the outside function, which is h of x, is of the form x to the fifth. So let's say h of x equals x to the fifth. That's like the general form. And obviously the inside function is 3x squared plus 4. So that one just stays the same. So now we can just apply the rule. F prime of x, the derivative of f, is equals to the derivative of the outside. So we're gonna just pull down this 5 in front and 3x squared plus 4. The inside stays the same and 5 minus 1. So we have an exponent of 4 and times the derivative of the inside function, which is 6x. We can actually do a little algebra and we get the derivative of f of x is 30x times 3x squared plus 4 to the fourth power. And this is it. We can just leave it as we can see here. And so make sure you review these three rules and do the examples again. And this is all for this video.